Welcome to today's lesson. I'm going to take you through a lesson in chemistry. So we go straight to the lesson. Well, today, as I indicated, we are going to look at a periodic table. Well, a periodic table was actually developed by a Russian by the name of Mendeleev, who arranged the elements on the periodic table using actually the relative atomic mass. So Mendeleev actually arranged according to mass. Very important. And so these elements were arranged in that order using the mass. Each atom, he arranged it, each element according to its mass. But the modern periodic table that we are using now, we are actually using the atomic number. You may be aware that the atomic number, if, for example, this is the element, the top part would be the mass number. And down here would be the atomic number. So according to the modern periodic table, actually it uses the increase in the atomic number. So elements are arranged in that manner. And so according to Mendeleev, the periodic table actually had gaps, and these gaps were meant to enable to actually replace the unknown elements that would be discovered later. Similar elements were grouped according to where, as I indicated, the mass number, according to the atomic number, according to atomic mass. This is according to Mendeleev. But the modern one, it uses the atomic number. So basically, this is the background. So typically, the modern periodic table is in that order. Well, I'll briefly explain really how the periodic table actually is arranged. It has groups. The groups are actually these vertical columns. These are known as groups. And so these groups on a periodic table, they are actually 8 of them. And then we have also the horizontal rows, actually. These horizontal rows, starting with this one where there's helium and hydrogen, there are 7 of them. So we have the first one here with only 2 elements. 1, 2, 3, 4, 5, 6, 7. So the last 2 here, these which are detached, actually, they belong to group 6 and 7. And so we have 7 periods, and we have 8 actually groups. However, if we included these, which is a block of elements actually between group 2 and group 3, these are known as transition elements or transition metals. These metals actually can be also be included in a group, and that makes the group now to have actually 18 elements, meaning these 8 plus these 8 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 plus the 8 here, which makes actually 18 of them. Well, the characteristics of the periodic table, as we said earlier, that the modern one is actually arranged according to the atomic number. And Well, now let's look at the period, as we indicated earlier, that actually the period are the horizontal rows on the periodic table. We indicated that actually there are 7 of them. And elements in a period are actually arranged according to the same number of actually electron shells, meaning that all elements in a row have the same number of electrons. And each element in a period actually would differ by 1 proton. Okay, and the metallic characteristic is going actually to be less to the predecessor. What it means is that actually, for example, we take period 2 here, where there is lithium. It means that if you check here, the atomic number is actually 3. The next one is actually 4. Then the next one is actually 5. So it will be actually increasing by 1 atom as we are going from left to right. However, also the metallic characteristic is going to do what? Is going to reduce. So the one which is actually, for example, with a less atomic number will be more metallic. So this one will be more metallic. That's across the actually the period. So lithium here will be more metallic than actually beryllium, and boron will be more metallic than actually carbon, and so on and so on. In that manner. So all elements in a row have as I indicated earlier on that predecessor actually will be less metallic. So there are only 2 elements in period 1, and with this one we indicated already that it's only in period 1 there is only helium. So this helium and hydrogen and helium here, they are actually the only elements in period 1. And in period, there are 7 actually periods we indicated already. Period 2 and 3 have 8 elements. Period 4, 5 have actually 18 elements, while period 6, 7 have actually 32. That includes actually the detached, which are pulled out as we indicated earlier. So in a period, actually, if you look at the electrons in the outermost shell, that is the valence electrons, we notice that actually they increase from 1 to 8. That is across actually the period, and 1 to 2 in period 1. What it means is that if you look at the period, for example, look at period 1 here, we notice that this one is going to have a valence 1, meaning there will be only 1 electron in the atmosphere. The second one, there will be 2. Boron, there will be 3. Carbon, there will be 4. Nitrogen, there will be 5. Oxygen, there will be 6. Fluorine, there will be 7, and so on and so on. So that's what actually means. The valence electrons are going to be actually increasing from 1 to 8. But for period 1, they will just increase from 1 to 2, because hydrogen has only 1 in the atmosphere and helium actually 2. So what about the valence in a period? The valence is the number of actually electrons which should be lost to enable that element to be stable, or also to be gained in order for the element actually to be stable. We note that from actually group 1 up to 4, the elements actually lose electrons, and then thereafter the elements actually gain electrons, and we've noticed that in group 8 actually they lose nothing. And so the atomic size it actually decreases from left to right, simply because actually the atomic number is increasing from left to right, and therefore the number of protons will increase as well as the electron, meaning that the electron, which is in the outermost bands far from the nucleus, will actually not be attracted more to the protons, which are positive. Also, metallic characteristics shows that, as we saw, that it is decreasing from actually left to the right across the period. What it means is that lithium will be more metallic than beryllium, and then boron will be more metallic than carbon, and so on and so on. So it is actually decreasing as you are going in that direction from left to right. Now, if we also now look at the group. What's the group? A group is actually a vertical column, which is actually on the periodic table, meaning that it is vertical. You are looking at the characteristics of elements in the vertical line, as we indicated. We said actually we had 8 groups here, if we don't include the transition metals. And we have actually 8 groups. Transition metals. And so elements in a group will have similar properties here. Why? Because in each group actually, you notice that the elements is going to have the same number of electrons in the outermost shell, meaning that they will all be losing actually. If you see losing one electron, that which is in the outermost, that will be the one which will be lost. And so, or if it's gain for them to be stable, in that particular group, they will have to gain the same number of electrons. And as we said, the group between 2 and 3 it comprises of actually transition metals. There are 18 groups of in a group if we included actual transition metals as we indicated earlier. In a group actually the atomic size actually from top to bottom it actually increases, meaning that the number of shells increases as you are going down the group, and you expect that actually the atom will be increasing in size as well. Then the valence electrons, that is the number of electrons in the outermost shell, we notice that actually they are the same in each group, and therefore the characters will be the same for that particular group. And then the valence, that is the number of electrons which will be gained or lost for an element to attain actually stability. We notice that actually they are the same as well. In a particular group, if the electrons have to be gained, for example, group 7, they have to gain actually 1 electron, all of them, which means that they have actually the valence of 1. And in group 1, we have 1 electron, so it is easier to lose that electron, and therefore the valence will be 1. The metallic characteristics actually increases down the group. Why? It's because actually the further away the electron is from the nucleus, the easy for it to be actually knocked off during a reaction, and therefore you notice that it is easier actually to lose an electron for an element with many shells. And so the naming of the groups actually, we notice that the group 1, they are known as alkali metals, group 2, alkaline metals, group 7, the halogens, and the group O, the noble gases or layer gases, And so this has given us at least a brief background of the periodic table. And so for those of you who would want to actually contact me, you can contact me through my email, which is ksiamasaka@gmail.com, and also WhatsApp +2609774199949. And so the services that I provide, actually, I can help you to solve assignments at an affordable fee. If you have assignments which are pending in physics and chemistry, I can actually solve for them for you, as well as a intensive coaching, actually, in a particular topic. If there is a topic that you feel you need extra lessons or extra understanding, then you can contact me, as well as actually online lesson in form of actually a video. I can explain thoroughly to you, as well as actually if you just want a video on a particular topic, you want fully to understand that particular topic, I can actually make one and then actually send it to you. And this all goes at a very affordable price here. So thank you.